A particle P of mass 0.3 kg is connected by a light inextensible string to a particle Q of mass 0.2 kg. The string joining two particles is taut and is parallel to the line of greatest slope as slope of the rough plane, which is inclined at an angle of 30 degree to the horizontal. A constant force of 12 newtons acts on Q and pulls the particle up the plane. The 12 Newton force acts parallel to the line of greatest slope of the plane. The coefficient of friction between each of the particle and the plane is 0.4. So 0.4 is equal to mu. Find the magnitude of acceleration and tension in the string. So I just draw the separate forces of P and Q down here. Let's just draw the components. So first of all, if it is 0.3 kilogram, the weight acts downward, so weight will be 0.3 into 10, which is G. So 3 newtons downwards. Now we'll draw the components. With theta, it will be 3 cos 30, as this angle is also 30, and this will be 3 sin 30. Now particle P is pulled by the tension, and friction is, this is also a reaction force, which is equal to 3 cos 30, and friction is 0.4 into R, which is 3 cos 30. Now let's just make an equation from this. T, tension, is the driving force, minus resistance, which is 0.4 into 3 cos 30, minus the component of weight, which is also acting parallelly downwards with the friction, minus 3 sin 30 is equal to MA. Now from here we'll get an equation which is T minus 3 whole 3 cube root square root 5 divided by 5 minus 3 sin 30, which is equal to 0.3, which is the mass times acceleration. Now for the particle Q, the mass is 0.2 kilograms, so weight will be 0.2 times 10, 2 newtons. This component will be 2 cos 30 and this component will be 2 sin 30. Now the driving force is of 12 newton. The tension is also present there, plus 0.4 times R, which is equal to 2 cos 30. So 0.4 times R. Let's make an equation from this as well. So 12 newton the driving force, minus 0.4 times 2 cos 30, minus the component of weight, which is 2 sin 30, minus tension is equal to MA. Equate this, you will get 12 minus T minus 2 square root of 3 divided by 5 minus 2 sin 30 is equal to 0.2a. Now if you add these both equations, this equation has a positive T and this has a negative T. If you add these both equations, you will get 12 minus 3 whole square root 3 divided by 5 minus 2 whole square root 3 divided by 5 minus 3 sin 30 minus 2 sin 30 is equal to MA, which is equal to 19 minus 2 whole square root 3 divided by 2, which is equal to MA. Now mass is 0.2 plus 0.3, so 0.5 times A We'll calculate A from here. A is equal to 15.5 meter per second square. Now you can put A back to any of these two equations. If you put it back here or here, you'll get the same answer. So if you put A, you will get, if you put A, you will get T is equal to 7.19 newtons. The B part says at the instant when the speed of particle is 2 meter per second, the spring breaks. Find the time it takes from the instant the spring breaks until P comes to instantaneous rest. So this is the plane for P. Now the upward force, the tension which was pulling P after the spring breaks, becomes 0. The friction is same which we calculated in the earlier part, 3 whole 3 square divided by 5, and the weight components are same as well. This is 3 sine 30. Now first of all, the driving force is 0. 0 minus 3 whole 3 square root divided by 5 minus 3 sine 30 equals to MA. We'll calculate A from here. Just divide this equation with M. M is equal to 0.3 as this is particle P. So acceleration will be equal to minus 5 minus 2 square root of 3. This is a negative sign because after the string breaks, there is no force which is pulling P to this position. So it will decelerate. Now we have an initial speed of 2 meter per second given in the question, and final speed is 0. So we'll use the formula T is equal to V minus U divided by A, and V is equal to 0, U is equal to 2, acceleration is equal to minus 5 minus 2 square root of 3, which is equal to 0.236 seconds.